Hey guys, this lesson is on working with normally distributed variables. So that means that we have a variable of interest that is normally distributed, which follows the bell curve. And I had a previous video on this where we were calculating the area under the curve using z-scores and z-tables, and then I showed you also with your calculator. So this is a continuation of that video. So if you haven't watched it, you might go back and watch it. Gonna share my screen in just a second and we'll get started. All right. There we go. So in the previous lesson, we were oftentimes given the z-score or the area, and we use the tables to help us find one or the other. So maybe you're not given that information, but you should be given enough information that you can find those things based on the information you're given. Remember that the area under the curve found from the z-scores is represents the percentage, not is the represents, it represents the percent of observations of that variable within a given range. And remember from my last video, maybe you had like 1.5 to infinity or negative infinity to negative 0.5 or whatever, but there's a range that we're looking for. Also, it is helpful to sketch the curve and shade the appropriate region before you start. This is really nice because it just gives you a picture as to what you're actually looking for. Sometimes when we're just trying to think about it in our heads, it's a little hard to tell what it's asking for, but if you can draw a picture of what you think it's asking for, it might trigger, oh, I need to find this in order to get this so that I can find my answer. And lastly, if you recall, we have found z-scores. The formula for finding a z-score is z equals the observation minus the mean over the standard deviation. If you need to write that out, that is the observation minus the mean over standard deviation. The observation might be X value or a data item or whatever. That just means that there's a particular observation, subject, whatever, piece of data that we're looking at, and that piece of data, that observation, has a particular z-score based on the mean and the standard deviation. So also recall that z-scores tell us how far an observation is from the mean. So we have an example here. A variable is normally distributed with a mean of 75. I'm going to highlight that because that's important. And a standard deviation of 10. Find the percentage of all possible values of the variable that, in this case, are at least 82. So when it says find the percentage, that means that you're actually finding the area under the curve. So in order to find the area under the curve, we need z-scores. So this is kind of a mathematical process, using these pieces to say, okay, I need a percentage. What represents percentage? Area. What do I need to find area? Z-scores. And so we're going to use all these pieces to help us figure this out. And I mentioned earlier that if you can sketch a curve, it can kind of give you a pretty good idea of what we're looking at. If you recall from the last video with the area under the curve, remember that the areas in the table represent the area to the left. And if we're desiring the area to the right, we have to do some subtraction and some figuring. So we're going to use that in today's a little bit. I'm going to sketch a curve. Let's see. Whoops. I'm going to draw my little axis on the bottom. And then I'm going to draw a rough bell curve. The mean is 75, and that is a measure of center. So 75 goes in the center. And then we have a standard deviation of 10. So it goes up 10 on that side. That's 3 standard deviations. And then it goes down 10 on this side, and that's 3 standard deviations. We're wanting the percentage of observations that are at least 82. So I'm just going to kind of guesstimate where I think 82 is. I'm going to say it's about here. At least 82 means that it's 82 or bigger. And I always think about this in terms of like shopping, because I don't know, money makes more sense to me. If I'm going to go to the store and spend at least $30, then that means I'm probably going to spend $30 or more. So that's what that means. At least 82 means that you're going to do 82 or more. So the shading would be, let me get blue here so I can go with my colors on this side. So I'm trying to figure out the percent of observations on this side of the graph. If I can get it in terms of z-scores, then I can find the area from my table. So I am going to find the z-score next. We know that z is our observation minus the mean divided by standard deviation. And then we're going to go ahead and subtract that. And then I'm going to put it in decimal form. And then let's just think about that for a second to kind of review. A z-score represents how many standard deviations an item is from the mean. So does positive 0.7 mean that this value is above the mean or below the mean? Positive means above. And then how many standard deviations is it above the mean? 0.7. So the value indicates how many, and the sign indicates which direction. So that's a good way to kind of check yourself, because obviously you can see this value is above the mean, so positive is good, and it's really not that far, so 0.7 makes sense. You can calculate the area using your z-tables. So if you want to pull out your z-tables, you go to, z-table, you go to the z-score of 0.7, and then find the associated area, or you can use your calculator. So pause the video. I want you to go try to find that on your own and then come back and check your work. Okay, if you used the table from your textbook, then you would have found that the area associated with a z-score of 0.7 is about, let me write this down, area from the table, we get about, I'm rounding, 0.76. So that's 76%. But remember that the area from the tables represents the left side. So we have to do one more step if we're going to use our table. Since we actually want the area to the right, we need to use the complement. And we get about 0.24. which is 24%. So if you're not using your calculator, you prefer to use the tables from your textbook, that's what you have to do. If you use your calculator, you're going to type in, you'll go to second vars, which is distribution, and then you're going to go to the second option. On mine, it's the second option. It's normal CDF. And whenever you're using your calculator, you're telling where the range is. So in this case, our range is from 0.7 to infinity. If you have a TI-84, it doesn't have infinity, so we're just going to put a really big number right there. You don't have to put exactly that many zeros. You just have to put a bunch of zeros. And then you can actually close the parentheses at this point, because your calculator assumes that this is a normally distributed variable, in which case a normally distributed variable has a mean of 0 and a standard deviation of 1. You might be confused because that's not what ours represents, but when we put it into a z-score, we standardize the variable. And a standardized variable has a mean of 0 and a standard deviation of 1. So the calculator assumes that it's standardized, and you don't have to put comma 0, comma 1. You can just close the parentheses because your calculator is going to assume this part. So if you standardize the variable like we did, then you can close the parentheses there, and it will give you 0.24, which is 24%. I do want to, however, point out that if you don't standardize the variable, so let's say you chose to skip this step right here. If you type in, do a different color here, go grab normal CDF, and we want from 82 to infinity with a mean of 75 and a standard deviation of 10, it will kind of do the z-score in the programming of it. It's hard to explain, but it'll do the z-score for you basically, and you should end up with 0.24. So go ahead and try it just to make sure you can get it. And you should see that we get rounded about 0.24, which is 24%. So this is just kind of showing you that you can do it 3 different ways. I wouldn't necessarily recommend doing it 3 ways. There's no reason to do that unless you're doing a test and you want to just double check yourself. You can pick one of these. You can do the area from the table. In that case, you'll have to remember that the area from the table represents the left shading. In this case, we want the right, so we have to do the complement. You can standardize the variable and just type it in that way, where you don't have to worry about typing in the mean and the standard deviation. Or you can do it this way, where you choose not to standardize the variable. And in this case, you have to specify the mean and the standard deviation, because then the calculator will standardize it kind of on the back end. So just pick one and do it. I don't want you to try to interchange both, because I don't want you to get confused as to, like, let's say you want to do this pink one here and you close the parentheses right there. You're not going to get the right answer because it's going to assume that the mean is 0 and the standard deviation is 1, because that's what the calculator assumes, and you won't get the right thing. So just be careful, choose one, go with that one, and you should be fine. So now I want you to interpret this result based on the information above and come back after you try it. So this means that 24% of the observations are at least 82 when the mean is 75 and the standard deviation is 10. That's all it means. That's a percentage. The area that we're finding under the curve represents the percent of observations within that range. You might recall from chapter 3, maybe, I think, the empirical rule, where we took a glance at the normal curve and we memorized these numbers that were, you know, however many percent lie within one standard deviation of the mean. That was 68. How many percent is within 2 standard deviation and 3 standard? And so we had this empirical rule where it just told us these percentages and we just accepted it as truth. Well, now we're saying, okay, well, what if I don't want exactly 1 standard deviation? What if I want 0.7? Or what if I want 2.5 or whatever? So we're taking the normal curve and we're kind of extending it a little bit, because we may not want those standard numbers that they've given us in the empirical rule. So moving on, I have another example. I want you to pause it and try it. and come back and check your work, I would strongly recommend going ahead and sketching the curve just so you can kind of see where you stand. Okay, so if you've sketched the curve, it should look something like this. Our keywords here, we are still using the mean of 75 and a standard deviation of 10. The key word here is at most 97. So that's the largest number it can be, which indicates I kind of sketched 97 to be about here, and then that would mean that we want stuff smaller than it, and then all the way to 97. So if we're going to standardize the variable, then you don't have to worry about finding the complement, because we are looking for the area to the left. So whatever area you find from the table is the actual area. So if you want to pause it and find that from your table or your calculator, go ahead and do that. So if you found the z-score, you should get 2.2, which means that this value is 2.2 standard deviations above the mean. If you used your table, since it is asking for the area to the left and the table represents the area to the left, you go down to 2.2 on the z table and 0 if you're going down from the top, and that puts you at about 0.99. And since this is area to the left, we don't have to use the complement. If you used your calculator, then you would go to second vars, click on select the second option, which is normal CDF. And we want to go from negative infinity, which is, we're going to use that number, to 2.2, close the parentheses since we standardized the variable, and you get about 0.99. And then if you chose not to standardize the variable, then you would have normal CDF still. You would still have negative infinity to 97, and then you would have to put in the mean and the standard deviation. So those are 3 different methods. No matter what method you chose, you should get 0.99 or 99%. And then that means that 99% of the observations are at most 97. Not so bad, right? So go ahead and try the next one. Pause it, try it, and come back. So you should get about 19%. You can see my work here if you need to pause it and take a look at it. If you standardize the variable, 80 represents a z-score of 0.5 and 87 represents a z-score of 1.2. And so if you're using your calculator, when you type that in, your range is from 0.5 to 1.2. Those are the 2 z-scores. If you chose not to standardize the variable, then your range is 80 to 87 with a mean of 75 and a standard deviation of 10. Both of those entries on the calculator should get you about 0.19, which means that about 19% of the observations fall between 80 and 87. Isn't that neat? So fun. Love this stuff. Let's move on. So I've already kind of mentioned a little bit the empirical rule. If you'll recall, the empirical rule states that approximately 68% of the data falls within 1 standard deviation of the mean. Remember that this only applies to a normal distribution or an approximately normal distribution. So if it's not, then you can't use this, but if it is, you can. And then 95% fall within 2, and then 99.7% falls within 3 standard deviations of the mean. I'm kind of rushing through that because we've already learned this. This is called the empirical rule, or the 68, 95, 99.7 rule. And here's kind of a sketch of that. So what I wanted to look at here was, when I taught this, I just gave you the numbers and I told you to memorize them, which is fine because it's what we had to do to get through that part of it. But now at this point, you can actually find those values on your own. So maybe you forgot the rules or the percentages in the empirical rule. Now you can use the fact that we know that the percentages represent an area between z-scores, and a z-score represents how many standard deviations it is from the mean. So knowing that and knowing how to use your tables or your calculator, you can find these percentages without having to memorize. So I've already kind of talked about this next question. How did they come up with the percentages on the inside of the curve? The percentages represent the areas from the z-tables. So just for a second here, I want you to use the z-scores. Remember that, sorry, rewind. Remember that this represents a z-score. -1 represents a z-score of a standard one standard deviation below the mean. +1 represents one standard deviation above the mean. So let's find this area real quick. It represents a range of -1 to +1. Those are the z-scores associated with those places on the scale. So either use your table or your calculator to find the area between z-scores of -1 and +1. If you had typed this into your calculator, you should get about 0.68, which is 68%. And that's so wonderful. So that's where that number came from. Now do it for 2 standard deviations and 3 standard deviations, above and below. So if you typed those in, you should get that when we are finding the area of a value that is 2 standard deviations above and below the mean, we get 0.95 for the area, which is 95%. Dun, dun, dun. And then when you do 3 standard deviations, so that represents -3 to +3, you get 99.7. Isn't that neat? Sorry, I keep saying isn't that neat, but I just think this is so cool how it all ties together. And then remember, we've already kind of talked about this a little bit. What does mu minus 2 sigma mean? That is the mean minus 2 times the standard deviation, which indicates that it is 2 standard deviations below the mean. So that can kind of help you read these little things. Pretty cool stuff. Next page. Okay, go ahead and try this one on your own and then come back and check your work. There's a couple things I want you to note about this problem. So it says you might sketch a curve first. So I did sketch the curve and I shaded the region I wanted. Also, you need to note that it says it is normally distributed. So I actually don't have to type anything in or look at my tables, because since it's normally distributed and this is the mean, how many standard deviations is 95 from the mean? 2. How many standard deviations is 55 from the mean? 2. And we already know that from the empirical rule, when something is within 2 standard deviations of the mean above or below, that the empirical rule applies. Oops. And we know that 95% lie within 2 standard deviations of the mean. So you can just approach this one logically, and that's kind of the advantage to sketching the curve first, because if it's normally distributed and you know how many standard deviations those items are from the mean, then since it's an even 2, 2 and 2, then we can use the empirical rule. Okay, something I want to cover next is percentiles. Percentile represents the, excuse me, hold on. Sorry. Percentile represents the percent of observations that are equal to or below the desired observation. So if you have had kids or have little siblings or whatever, this is probably the most popular time you hear of this. When you take a little baby into the doctor, they say, your baby's in the 90th percentile, or your baby's in the 50th percentile, or the 45th percentile, or whatever. And everyone's like, what does that mean? What that means is, if your baby is in the, we'll say, 75th percentile, that means that your baby's, for weight, we'll pretend. They've weighed your baby and they say, your baby's in the 75th percentile. That means that your baby is weighs more than or equal to 75% of the baby's measured. So that's kind of big. If they say your baby's in the 99th percentile for height, that means that your baby is really tall, because that means that your baby is taller than 99% of the other babies. So we can use percentiles. They use it a lot in like SAT, ACT type of stuff. If you're in the 90th percentile, then that means you're smarter than 90% of the students who were tested, which is really good. If you're in the 99th percentile, then you're like super, super smart. So we can obtain percentiles using the stuff that we've already learned in this video. So I want you to try this on your own. Come back and check it. All right, so if you drew a sketch, it should look something like this, where based on the definition of percentile, percentile represents the percentage less than or equal to that percent. So I just kind of sketched where I thought 90% would be. And since we're given the percent, in this case, we're given the area. So the area is 0.9, and that indicates the inside of the curve. And we're going to use that area to help us find the z-score associated with 0.90. So if you're using your z-tables, we're actually given the value inside the table, and you're using that to find the z-score on the outsides. I think you have to end up rounding. It's like 0.899 is the one that's going to get you the closest. If you're using your calculator, you're going to be using inverse norm, which means we're going the opposite of normal CDF. And you can actually close your parentheses here because it assumes 0 and 1. I'm just used to writing it in there. So if you did, that's fine. And you should get about 1.28 for the z-score. Now I came back from pausing the video because this part I haven't really explained. If you did it, that's wonderful. We're hoping to find the x value associated with the 90th percentile. So the z-score formula, I have a z-score and I know a z-score formula. X minus the mean over standard deviation. I have z, I have the mean, and I have the standard deviation. I believe for the example above. I was going to say, maybe not. Okay. So I know that z is 1.28. I'm looking for x. I know the mean is 75, and I know the standard deviation is 10. So we're going to have to do a little bit of solving here. To do that, you're going to want to multiply both sides by 10 so that these divide to 1. We'll get 12.8 equals x minus 75. Then we're going to need to add 75. And we get 87.8. So if we wanted to round it, we could round that to 88. Which means that an observation of 88 is in the 90th percentile. So if we were given, in the previous examples, we've been given this, and we've been asked to find areas. In this example, you were given the area, and you have to use that to help you find which value has that area. So, pretty cool. We can go both directions now. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know, and I will be more than happy to help.